our first two chapters in this part are about how we collect data. So in the first unit, you were just given tables of data, and we didn't really worry about where that data was coming from. So in the first two chapters, Chapter 8 and Chapter 9, we're going to look at how we can actually collect data from the beginning. So if we have a question that we want to answer, how can we get the data that would allow us to answer that, and then we could evaluate the data based on graphing or means or medians or other things that we'll learn throughout the course of this unit as well. In this chapter, Chapter 8, we're going to talk about sampling. So when we sample something, we're doing an observational study. So a big key to understand first here is what is the difference between an observational study and an experiment. An observational study observes individuals, measures a variable of interest, but does not attempt to influence the responses. Okay? We're trying to describe a group. In observational study, we watch people, right? Or we ask them questions. But we don't do anything to try to affect the outcomes. In an experiment, we are deliberately imposing a treatment on people to observe their responses. And the purpose to see is whether doing that causes a change in responses. So, for example, an observational study would be asking 100 people, do you like Coke or Pepsi better? Okay. An experiment would be, you have 2 cups that are unlabeled, drink cup A, drink cup B, which one do you like better? Okay. There we're doing some sort of a test on the people. Okay. And then we'll talk more about it in the next chapter when we talk about setting up experiments, but to do that accurately and adequately, we would have to alter it so that the first thing they drink is not always the Coke and the second thing is not always the Pepsi, because sometimes the order that you do something can affect your answer on that. So we would have to randomly assign which one they would end up drinking first. But an observational study, we're asking people a question or we're just sitting back and watching what happens. And an experiment, we're doing something and then watching what happens. Often in an observational study, we may have what's called confounding. Confounding is when there's more than one variable that may be affecting the outcome. And we talked about in the first unit these lurking variables, these things that are happening kind of behind the scenes. So on the test it asked what could maybe be like a lurking variable in terms of why somebody would do better the second time they take an SAT than the first time. Maybe it is that they took a prep class, or maybe it's that they're a year older and so they're further in their studies in school, or maybe they studied on their own, or maybe they just had no idea what an SAT was before and now they do. So there's different things that could be affecting it in addition to or instead of that actual taking a course. So those lurking variables can confound our results and make it kind of unclear what the true conclusion is in an observational study. So an example that the book gives about this, it says, moderate use of alcohol is associated with better health. Observational studies suggest that drinking wine rather than beer or spirits confers added health benefits. So if you drink a little bit of alcohol, they say it shows that you're a healthier person than if you don't drink any. And wine is better than beer or liquor. But there's something else that's going on here. They didn't tell people, you need to start drinking 1 glass of wine every day and I'm going to watch what happens to your health. These people are choosing to drink wine. And wine drinkers are a different breed of people in general. Wine drinkers and beer drinkers are typically 2 different kinds of people. Typically, wine drinkers are of a higher class. They typically eat healthier. It's typically a glass of wine with dinner, as opposed to beer drinkers who usually lead a less healthy lifestyle and drink more beer. So there's something else happening here. It's not necessarily the wine itself. It may be a whole lifestyle thing. And so that would be some confounding that would happen because of those lurking variables of lifestyle. A population is the entire group of individuals that we want to answer a question about. The whole thing. So all high school students nationwide. Okay? A population is typically a very large group. Okay? It is impractical to do an observational study or an experiment on an entire population. There's really no way that I could answer a question about something about high school students and ask every single high school student in the country. There's no way I could do that. So what we do is sample. And when we sample, we're going to take a part of the population and get answers from them and hope that that is representative of the whole population. To have that be true, we need to be careful in how we choose that sample. Because if I'm trying to answer questions about high school students nationwide, and I ask 50 students from North Point Christian, likely my sample is not going to be representative of the population, right? We need to consider private, public, urban, rural, across the country. We need to represent anyone from any different type of category that could have a different opinion than students at North Point Christian. And even within the schools, make sure that we're asking like freshmen to seniors. So that's where sampling design comes into play, and that's how we choose to pick our sample. The best way to choose to sample is something that's called random sampling. The book, after introducing this idea of what sampling is and taking, they compare it to if you have a whole bowl of soup, you can take one spoonful, and then after you have that one spoonful, you have a pretty good idea what the soup tastes like, right? Because the bowl is the same. Like, soup is soup through and through. As opposed to people are not really just people through and through. People differ in their opinion. So we need to be careful kind of what spoonful of people we're taking. So sometimes it's easier to describe the good way of doing things. Sometimes it's easier to describe what would be bad to do and say, don't do this. And so that's where the book goes on this, is how do we sample badly? What would be some bad choices to make in sampling? So one thing that I said is, like, if I wanted to know about high school students across the country in general, and I just asked students from North Point Christian, that would be a bad way to sample. Okay? That would be what we call a convenient sample. It would be very easy for me to ask 50 students at North Point Christian. It would be much harder for me to actually get data from students across the country. But it would still be a bad idea to do this convenient sampling. Convenient sampling is often done at malls. So I don't know if you've ever had this at a mall and you're walking and you see somebody with a clipboard and you like try to run the other way because you know they're going to start asking you questions. That's a convenient sample. They just stand there and wait for people to walk by them and ask them questions. Okay? That's just convenience, to be in one place where you're going to have a lot of people around you. Convenient sampling often has bias. Bias happens if it systematically favors certain outcomes. So sometimes when you choose a sample, even if I do so randomly, it could, because it's random, I could have randomly selected more urban students than rural students. Okay? That's just the way random works. Random doesn't mean 50-50. Random means anything can happen. But that's not biased. It just happened on accident. Bias happens if every time I would do this, I'm favoring something. Okay? Shopping mall samples are very biased because there are certain types of people who go to malls and certain types of people who don't. Okay? So if you're doing a mall sample, typically you're going to underrepresent the poor part of the population because they're not shopping, likely. Right? You're going to underrepresent, depending on the time of the day, the working population. If you're there on a Tuesday at 1 o'clock in the afternoon, the people that are working are not going to be a part of your sample. So you're going to end up missing some groups of people by doing that. Also, the mall that you go to could make a big difference. I mean, the clientele at Woodland is very different than the clientele at Rivertown. So depending on which mall you choose, you're going to get a different answer. So these are biased because every single time you're going to end up favoring certain groups over other groups. A voluntary response sample is when people choose themselves to be a part of your sample. This is a horrible way to sample, but it is a very easy way to sample. Our school does this all the time. Okay? Statistically, it is a horrible thing to do, but it is an easy thing to do. So several times a year, the school sends out surveys to your parents to ask them, how things are going, what they would want to change. The only people that are going to respond to those are the people who have strong opinions.
Dinner time question.
Right? Those are the only people that are going to respond to those, are the people who have strong opinions. We also, at the end of the year, send out evaluations to your parents to fill out about their teachers. So at the end of the year, your parents will get an email asking them to evaluate me. Likely, the only parents who are going to respond to this are parents who have either had a very good experience with me throughout the year or a very bad experience with me throughout the year. And we're going to miss the 90% of students who just kind of sat in my room and it was kind of a non-event for them throughout the year, right? We're going to end up with only the really good and the really bad responses. Voluntary sampling is like the worst possible way to sample. But it's the easiest way. I mean, how's our school going to say every parent must fill this out? Well, what if they don't? What are we going to do to them? So we can't force it. It has to be voluntary, but it really doesn't give good data in the end. So the best way to get good data is what we call a simple random sample. We abbreviate it SRS. A simple random sample consists of individuals of the population chosen in such a way that every set of individuals has an equal chance for the sample to actually be selected. So in a simple random sample, the easiest way to think about it is put everybody in the entire population, whatever group you're studying, put all of their names in a hat and start drawing out names. Okay? Every single one of those pieces of paper would have an equally likely chance to be drawn out, and any particular group would have an equally likely chance to be drawn out. Okay? That's a simple random sample. Each individual person, and then if I'm saying I'm going to take a sample of 100 people, every single group of 100 people would have just as likely of a chance. Okay? It is possible, it's very unlikely, but let's say I was going to do a study on high school students in Michigan. We'll kind of reduce our population here. High school students in Michigan. And I'm going to take a sample of 300 students. Okay, that would be a small sample. That wouldn't be a good idea. Bigger samples are better, but let's say I was going to take a sample of 300 students. It is possible that doing a random sample, all 300 of my students could be North Point students. It's not likely, right? It's not likely. But random means anything can happen. So it is possible that all 300 actually came from the same place. It's just not likely at all. People have a very bad idea of randomness. To us, randomness we think of as being, I should have one student from this school, one student from this school, one student from this school, one student from this school. And that's not the way it is. Anything can happen in a simple random sample, and is just as likely to happen as anything else. To find a random sample, we can use technology. Your calculator has a random number generator on it, and so what we would do is assign everybody in the population a number. The number we assign must be of equal length. So in the book on page 197, they want to take a sample of some spring breaker sorts. They have 28 of them, and they want to call 4 of them. Okay? Because there are 28 of them, all of the labels must have 2 digits. So we don't just label the first one 1, we label it 01. Okay? All of the labels must be the same length. So if you have 10 things, you need to start into having two, well, you can still do one label, because you could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Once you have the 11th thing come in, now you need to do 2 digits. 0, 1, 0, 2, 0, 3, 0, 4, up to 11.
No.
You
Is
can
that
use,
binary?
not quite, because we're still gonna have like 15. Yeah. You could label 100 different items, different members of a population with 2 digits. Because you would go 0, 1, 0, 2, 0, 3, 0, 4, etc. on up to 98, 99, 00. You just would put the 1 in front of it. So you'd still have 100 unique labels. Once you now have 101, then now we need to go into having 3 labels. And we can do that up until we have 1,000 things. Okay? But all of those labels need to be of the same length. So we label them all out. And then we could use technology. You could use a calculator to give you a random number, and it would just spit out random numbers for us. I'm not really going to have us practice that because all of your calculators would give you a different random number. So in your homework, some of your problems are going to ask you to do a random selection. And if you do it on your calculator, you're all going to have different answers, which is good. That's what we want randomness to be, but it's bad in terms of checking if you're doing stuff right. So we're going to use a random number table, which in the back of the book is table B. It is on page 686. And that table was created by a computer, and they told the computer just spit out random digits, and that's what it did. In the table, they're kind of grouped into groups of 5 digits, and then they're put into some rows. That grouping means nothing. It just makes it easier to read the table. So, to show how we would use this, on this spring break problem, and randomly selecting which destinations to interview, our labels go from 0, 1 to 28. So what we're going to do is you choose a line of the table. It doesn't matter what line you choose. In the homework, it will tell you, using table B, begin at line 130. Begin at line 104. It'll tell you which line to begin at, but if you're doing an experiment, you just pick a line. It doesn't matter because it's all random. So there's no bias in saying like, I like number 120 best. I'm going to choose that one. Doesn't matter. Okay, you can pick any line you want. For this particular problem, we're going to, let's see, start at line 130. So in the example it says that we're going to start at line 130. So what we do is we look to line 130. Line 130, I start reading off the digits. 6, 9, 0, 5, 1, 6, 4, 8, 1, 7, 8, 7, 1, 7, 4, 0, 9, 5, 1, 7. I'll see if that gets me far enough. Okay, but I'm just taking the digits across. I didn't put the spaces in there because the spaces actually don't matter. Now, all of our labels are 2 digits, 0, 1 to 28. So what we're going to do is break this into groups of 2s. Oops. So the first one is 69. I don't have something labeled 69, so that doesn't help me find my sample. The next one is 05. I do have something labeled 05, so 05 is the first member of my sample.
How many do you need?
It'll tell you in the problem how big of a sample you're choosing. In this particular one, we're choosing a sample of 4.
Okay, so we just need 4.
So then the next one is 16. Okay, so I can do that. The next one is 48. I don't have a 48. The next one is 17. So I can do 17. And this is where people start to feel uncomfortable about this being random. It's like, oh, but I already have 16. 16 and 17, those are right next to each other. I shouldn't do that. They need to be more spaced out. Random does not mean spaced out. We could end up having 4 in a row. That's what simple random sample means, is it's just as likely to end up having 4 in a row as it is with having any other 4 numbers.
Wait, are we trying to pick out numbers here that are in between 1 and 20? Oh,
Yes.
okay. I was
So the next one is 87, I can't do that. The next one is 17, I've already done that. The next one is 40, I can't do that. 95, there isn't a 95, 17. So then I need to go back to my table and I need to grab more digits. So, how far did I take this to? 9, 7. So then the next group I get 8, 4, 5, 3, 4, 0, 6, 4, 8, 9, 8, 7, 2, 0, 1, 9, 7, 2, 4, 5.
3 groups of 4.
No, I'm just writing down the rest of that row. So then 84, we don't have an 84. So we can't do 84, we can't do 53, we can't do 40, we can't do 64, 86, 87, 20, we can do 20. So that's our sample. If I made it all the way to the end of this row and I still didn't have as many as I need, let's say I needed a sample of 6, so I would just keep on going. So then the next one, 19, okay, I could do 19, but 72, 45, and I only have 5 and I made it to the end of the row, you just go to the next row and start writing down the numbers from that row. Okay, so you just pick a row to start at and then just work your way through the table. And it says really, since this table of numbers is totally random, instead of doing rows, you could actually do columns of numbers too. And it doesn't matter. Because all we're doing is looking for numbers.
So I
And
can
it doesn't
just,
matter how we look for those numbers.
So I can just write down random numbers and you wouldn't
People cannot write down random numbers. That's what I'm saying. Like, we have such a bad feeling of random
Right.
that we can't write down random numbers. But we could read this table in any direction, forward, backward, up, down, it doesn't matter. But it does say that kind of as standard practice for consistency so that we're all seeing what each other are doing, we're just going to read it as we would normally read a table from left across to right and move down rows. But really, we could do whatever we wanted. And that is the end of what we need to do today.